Welcome back to Pocket Run. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Okay, we're going to be doing boat and plane problems. When you're a boat and you're going on a river, okay, so here's our river and here's the water, and the water is flowing that way, going downstream, and you're the boat. Here's my failed attempt of a boat. There's my boat. So when you are going downstream, or if you're a plane and you're flying with the wind, when you're going downstream means you are going with the current, or if it's a plane, with the wind. When you're doing that, then the rate, I'm going to call this the rate of downstream. We're going to be dealing with distance and rate problems again. Distance equals rate times time. When you're going downstream and you're going with the current, you have to deal with the rate of the current, the rate of the water, and the rate of the boat. So the rate going downstream is going to be equal to the rate of the boat plus the rate of the water, because you have a boat traveling with the water. When you are going upstream, you are going against the current, and so where you have a rate of upstream, that's going to be equal to the rate of the boat minus the rate of the water. So you can see that these both look similar except their signs. When you're going downstream, you add the boat's rate and the water's rate together. When you're going upstream against the current, you take your boat minus the rate of the water, which makes sense because if you're going, this is downstream, the boat's pointing that way. But if I was going to be going upstream, here's my boat, and so the boat's traveling that direction and my water's going the other direction. Aragorn paddled 12 miles upstream in the same amount of time it took him to paddle 60 miles downstream. The rate of the current is 4 miles an hour. What was the rate he paddled? So what was the rate he paddled? That's the rate of the boat. And what was the total time of his trip? So this keyword total time. Okay? So in other words, how long did it take him to go upstream and then turn back around and go downstream? Okay, this is my best suggestion for keeping up with all your information in the problem. So you can draw a picture if you want. Basically, he is paddling upstream and then he's going to turn around and go downstream. Okay, so my recommendation is there's your upstream information and here's your downstream information. We're going to keep up with that. Okay, so I do know it says that Aragorn paddled 12 miles upstream. Okay, that's my distance. 12 miles is my distance of upstream. So I'm going to call this DU. And then the problem says in the same amount of time it took him to paddle 60 miles downstream. So the distance he went downstream distance is 60 miles. That sentence just told me it took the same amount of time. So I'm just going to write somewhere here in the middle, the time for upstream is the same for time as downstream. Okay, time of upstream is equal to time of downstream. Okay, then it also tells me the rate of the current is 4 miles an hour. The rate of the current is always the rate of the water. So I'll label that RW for rate of water is 4 miles an hour. You will be able to use this information in both of your equations for upstream and downstream. Then it says what was the rate he paddled? That's the rate of the boat. We don't know that. And then the total time for the trip. Okay, so we want to know the total time. So let's just look at upstream and go back to upstream. So we know that distance equals rate times time. So we can make this equation here. We can also make our same equation for downstream. Distance equals rate times time. But I'm labeling everything. This is all for downstream. This is all for upstream. Okay? A minute ago, we just wrote equations for our rate. Okay? The rate of upstream, when you are going upstream, you have to take your boat minus the rate of the water. Okay? Now let's go back over here to downstream. When you're going downstream, the rate of the downstream, when you're going downstream, you're going with the water, with the current. So you can take the rate of the boat plus the rate of the water. Okay, now I have all my equations written down. Let's now start substituting in the information that we know. Okay, we're going to go back to this distance equals rate times time equation. So I know that my distance of my upstream is 12 miles an hour. So that can go right there. RU is equal to the rate of the boat minus the rate of the water. So RU equals this whole thing. So we can take this whole thing and put it right in there for RU. Okay, so I'm going to write that. So basically I'm coming back to this equation right here for my distance equals rate times time. My distance of my upstream is 12 equals my rate of my upstream, but the rate of the upstream equals the boat minus the water. I substituted this whole thing for RU. So then I still have TU right there. I'll deal with that in a minute. Now let's go over here and do the same thing to my downstream. Okay, so over here in downstream, I know this piece of information, that my downstream distance, so I'm going to put that right there for my distance. Then this whole thing equals the downstream rate. And I'm going to substitute that in right there for my downstream rate. Okay, so coming back to distance equals rate times time, putting in 60 for my downstream distance equals the rate of downstream. I'm going to substitute this whole thing. The rate of downstream is my boat plus my water. The rate of the boat plus the rate of the water times the time of downstream. Okay, now let's go back. What did we say about the time? We said that the time of downstream is equal to the time of the upstream. So instead of using TU and TD, we can just call it just T because the times are the same. So since the times are the same, I don't need to label it upstream or downstream. I'm just going to call it T. But we need to remember it's either upstream or downstream. I could either call them both TU or both TD. So with that being said, let's look at what else do we know from the information from the problem. We were told that the rate of the water is 4 miles an hour. Okay, so we can plug that in right here. It's the same for both upstream and downstream. Okay, the rate of the water is the same. That doesn't change. So we can go plug in that information. So 12 equals, that was our distance, and then the rate of the boat minus, keep up with your signs, the rate of the water we were told was 4 miles an hour times our time. Come over here to your downstream equation. 60 equals, or that was the distance, the rate of the boat plus the rate of the water, which is 4, times your time. Okay, now you only have 2 equations and 2 unknowns. You need to get down to where you have 2 unknowns, because I would call this equation 1 and equation 2. We have 2 unknowns now, and now we've gotten down to 2 equations. So we can take these 2 equations and then use elimination to solve for our 2 unknowns. So how I'm going to do that is I'm going to distribute this T. So I'm going to call this R, rate of the boat, T minus 4T. All I'm doing is just distributing that T. I'm going to come over here and do the same thing with this equation. I'm going to distribute that T. So we have RBT plus 4T. So I have 2 equations and 2 unknowns. So I'm going to use elimination. To do elimination, you take these 2 equations and you stack them on top of each other. So I'm going to take this first equation, and then I'm going to stack my other one right on top. I'm going to keep everything lined up. Here's all my distances. Here's RB, T, and then all my T's. Line everything up. If you add them together, you see that your T's eliminate. Don't eliminate those. You want to eliminate, you don't want to have two variables that you're trying to solve for at the same time. Okay? So this RBT that looks strange, that's what you want to eliminate. Don't eliminate these, because we're going to eliminate this weird looking thing and then solve for T. So if these are both positive, so one of them has to be a negative. So if we multiply everything by -1, it changes the sign of everything. Now we can add our equations together. Those weird looking things eliminate. Now we can add this. Be 8, 48. I think I did that correct. 48 equals, add these, 8t, divide by 8. Now t equals 6, and then the units I was working with for time was hours, because everything was in miles per hours. So that would be hours. But what did that t represent? That t represented either the time of the upstream or the time of the downstream. Time of the downstream equaled the time of the upstream, which is 6 hours. The question actually asked what is the total time of his trip. So it took him 6 hours to go upstream, and then he turned around and went 6 hours downstream. So my total time is 12 hours. That just answered one of the questions, okay? The other question that it asked was, what was the rate of the boat, or what was the rate at which he paddled? So we need to take this. Actually, we need to take this one, because this was the time of the upstream or the time of the downstream. We need to take this. Can you see these equations? And plug this back into either one of these equations. Remember, these were our two equations with our two unknowns. I would label, when you get your equations down, I would somehow label them so you know what equations to go back to. Because if it doesn't matter which one you pick, you will get the same answer. Okay, if you want to pick the one that has the positive, great. You will get the same answer either way. We can take our time, because remember, this t represented time of the upstream or the time of the downstream. Okay, so we can take this 6 and substitute it back in for this t right there, and then we can solve for our the rate of the boat. So going back to this equation right here, 60 equals the rate of my boat plus 4 times my time of the upstream or the downstream. If you want to leave this as a U, that was fine to help remind you. So my time of my upstream, which was the same as the time of my downstream, was 6. So now I only have one unknown, which is the rate of the boat, and I can solve for that. Distribute this to both things, or you can divide it over and get rid of it, whichever you want to do. So 60 equals 6 rate of the boat plus 24. Subtract 24 to both sides. Let's see, that would be 6. 3, 36 equals 6 times the rate of the boat. Divide both sides by 6. So 6, and then it was a rate. So what are the units for rate? Miles per hour is the rate of the boat. That is the rate at which he paddled. Okay, we're looking at 29B, number 7. It's dealing with the plane going with the wind and against the wind. It's the same philosophy as a boat going with the current or against the current. Okay, so we have a small plane, flew at a speed of 100 miles an hour. It took 6 hours to get to its destination flying with the wind, and then 9 hours to return against the wind. How far away was the plane's destination, and what was the wind speed? Okay, so basically the plane took off here, and it went somewhere, and it landed here. And so here's where it started, Here's where it ended. And then when it landed here, it went back to the same place. So what do we know about those distances? They're the same. Okay, so I'm just going to call this downstream and upstream. So it's the same thing, with the wind against the wind. Downwind, up the wind, against the wind. Okay, it's the same philosophy, so I'm going to use the same things that I'm telling you to write on your formula sheet. So the one thing that we can say is his downstream distance is the same as the upstream distance. Okay, I'm going to use the same philosophy as keeping track of all your information. I recommend you have the way you organize your work is you write everything for downstream and then you write everything for upstream. Okay, downstream is with the wind and upstream is against the wind. Doesn't matter if you're in water or you're in wind, it's the same philosophy. Okay, so for downstream we can say the same distance equals rate times time. So the distance equals rate times time. That's everything for downstream. That's why they all have a subscript of D. Now, distance for upstream equals rate times time. Now, the rate of the downstream, when you're flying or in the water, the rate of downstream is the same. You take your boat plus your water. In this case, it's a plane plus the wind. Thankfully, wind and water both start with the W, so we can leave the W. I'm going to go ahead and leave the B, even though we're dealing with a plane and not a boat. Okay, so just know that's a plane, but I'm still going to leave it a boat because that's what we're writing on your formula sheet. For upstream, the rate of your upstream, your boat is always going to be subtracted, boat minus the water. Okay, or in this case, the wind. So the plane minus the wind. Okay, now let's go back to the problem, the information that was given to us. It says a small plane flew at a speed of 100 miles an hour. So that's the rate of our boat or our plane. It will be the same. We will use that for both cases of upstream and downstream. Okay, so the other thing it told us, it took 6 hours to get to its destination flying with the wind. When you're with the wind, you're going downstream. So that was our time. Time of going downstream was 6 hours. Then it said, and 9 hours to return against the wind. Against the wind is upstream. So the time it took going upstream is 9 hours. Okay, that was pretty much everything that was given. Now we just need to start taking everything that we know and see if we can start plugging it into our formulas. So, alright, so if we go back to, okay, we said that the distance of downstream is equal to the distance of upstream. So that's what I'm going to start with, okay? I said that the distance of downstream is equal to the distance of upstream. Because wherever the plane started, it took off and then it landed and then it took off again and went back. Okay, so now we can put in the rate. Distance equals rate times time. So you have rate times time for the downstream is equal to the rate times time of the upstream. Alright, going back to what do we know? Well, we do know that the time it took to go downstream, and we do know the time it took to go upstream. It told us that. Our rates. You go back to these equations right here, and so the rate of the downstream equals all of that. So you can take all of that and substitute it in right there. Same is true for the rate of the upstream. Rate of the upstream equals all of that. So you can take that and substitute that in right there for rate of the upstream. Okay, so let's make these substitutions. The rate of the downstream is this whole thing in the circle. So we can replace it with the boat plus the wind, or the plane plus the wind, times the time of downstream, which we said was 6 hours. Now we can make this substitution. The rate of the upstream is the boat minus the wind, the plane minus the wind, times the time of upstream, which was 9. Okay, so we still have two unknowns. We have one equation, but we have two unknowns. So either you have to know more information or have a second equation. Well, let's go back to more of the information that we were told. So we were told that the rate of the plane, I'm just using the boat subscript, the rate of the plane is 100 miles an hour. Okay, so I know that and that. Okay, it's the same. You use the same number, so now we can put in 100 for my RB. And so now I'm down to one unknown, the rate of the water, okay, or the rate of the wind. So to solve this, I can distribute this on both sides. So that will be 600 plus 6 RW equals 900 minus 9 RW. Now I need to get my unknowns on the same side and numbers on the other side. So I'm going to add 9 to both sides. That goes away here. So I have 600 plus 15 RW equals 900. So now I'm going to subtract my 600. So I can get unknowns on one side, numbers on the other side. Divide both sides by 15 so I can solve for my unknown. So the rate of the wind, 20, 15 and 30s, yeah, 20 to 300, okay, 20, and then rate is miles per hour, okay? So let's go back to what the problem was asking. The problem was asking how far away was the plane's destination and what was the wind speed. So this is one of the answers that we're looking for. But then it was asking the distance. How far is the plane's destination? So remember we said that the distance of the downstream equals the distance of the upstream. So it doesn't matter which one we deal with. Distance equals rate times time. So distance equals rate times time. I'm just going to use the downstream information. So I have to go back to going back to here. So distance equals, what is the rate of downstream? Rate of downstream is the rate of the boat plus the rate of the water times the distance of times the time of downstream, which was 6. I now know both of these pieces of information. Okay, so my distance is the boat, in this case the plane. Our plane was 100 miles an hour. And then our wind, we just solved that, was 20 times 6. So 100 plus 20, 120 times 6. So that should be 720 miles would be your distance. Okay, now we're looking at 29C, 9 through 12. Noah took 4 hours to go 36 miles downstream. Later that same day, it took him 3 hours to cover 15 miles upstream. What is the rate of the current and the rate of the boat? Okay, so we're dealing with water in a boat. So anytime with these problems, you're going to have downstream information and you're going to have upstream information that you need to keep up with. Okay, downstream, I have a distance equals rate times time. For my upstream, I have a distance equals rate times time. When you're going downstream, the rate downstream is equal to the rate of the boat plus the rate of the water. When you're going upstream, the rate upstream is equal to the rate of the boat minus the rate of the water, because you're going against the current. Okay? Now we can let's go back to the problem and write down what we know so that we can start just filling everything into our equations, okay? So, going back to the problem, Noah took 4 hours to go 36 miles downstream, okay? So downstream information, we are given our distance of downstream is 36 miles, and we're given our time of downstream was 4 hours. Okay, then it says, later that same day, it took him 3 hours to cover 15 miles upstream. Okay, so that's our upstream distance is 15 miles. And then our upstream time took him 3 hours. Then it says, what is the rate of the current and the rate of the boat? We want to know what is the rate of the water and what is the rate of the boat. What we're given a distance and a time. Distance equals rate times time. Okay? So we can take this, looking up here at our distance equals rate times time for downstream. We were given the distance and we were given the time. So we can actually solve for the rate of the downstream. Okay? So going back to here, the distance was 36 miles. Don't know the rate of the downstream, and then the time to go downstream was 4. We can actually solve from our rate of downstream. Divide 4 to both sides, and the rate of my downstream is 9 miles an hour. Okay, if you go over here to your upstream, same thing. We were given the distance of upstream, and we were given the time of upstream. So we can determine our rate of upstream. So putting this information in, start with this equation I'm pointing to. The distance equals the rate upstream times the time of upstream. Divide both sides by 3, and the rate of upstream is 5 miles an hour. We're not done. The problem did not ask us what is the rate going downstream and what is the rate going upstream. The problem asked for the rate of the boat and the rate of the water. Okay? But we can make equations of that because we have written up here that the rate of downstream equals the rate of the boat plus the rate of the water, and then the rate of upstream is the rate of the boat minus the rate of the water. Okay, so we just now calculated that, the rate of the downstream, and we calculated the rate of the upstream. Okay, so let's plug in what we know. The rate of the downstream is 9. We don't know the boat, and we don't know the water. Over here, the rate of the upstream was 5, and we don't know the boat, and we don't know the water. These are our 2 equations and our 2 unknowns. Okay, I have equation 1 and I have equation 2. Those are my equations 1 and my equations 2. I have 2 unknowns and I have 2 equations. So I can take these, stack them on top of each other, and use elimination to solve. So I have 9 equals the rate of the boat plus the rate of the water. 5 equals rate of the boat minus rate of the water. Everything is lined up. Here's all my numbers. Boat, water. I'm adding these. Does anything eliminate in the way it is right now? Yes, it does. The rate of my water will eliminate already like that. So those already cancel. Now I'm just adding these. That'd be 14. One of these plus one of these is 2 of these. Now dividing both sides by 2, then the rate of my boat is 7, and then rate is in miles per hour. That was one of the things that they were asking me. I need to go back and solve for the other thing. So I'll go back to my 2 equations that I had and my 2 unknowns. It doesn't matter which one you go to. I'm going to take this and plug it back in right there, because then I can solve for the rate of my water. Okay, so if I put that in there, 9 equals the rate of my boat is 7 plus the rate of my water. Subtract 7 from both sides, and then you can see that the rate of my water is 2 miles an hour.